Swayam Prabha. Digital India. Educated India.
Let us start our today's lecture for NPTEL video course on geotechnical earthquake engineering. So, for this video course, currently we are discussing with module number 6, which is dynamic soil properties. So, a quick recap what we have learned in our previous lecture. As I have already mentioned, the basic reference for this course, I will refer to my another video course of NPTEL, that is on soil dynamics, module 4 of that course, where I have discussed in detail about this dynamic soil properties. Now, in the previous lecture, we have discussed about what are the most important dynamic soil properties. In that, we need to know first about the density or unit weight of the soil, then shear modulus, which is a important dynamic soil property, and damping characteristics, another important dynamic soil property. We have seen how shear modulus is defined. It is nothing but the behavior of any material, for our case it is the soil, when it is subjected to cyclic shear stress. So, this is the shear stress versus shear strain plot. The slope of that curve will give us the shear modulus. So, it is defined as the ratio of shear stress to shear strain, as we all know. For a linear material, that is a material which is behaving linearly, we will find out that this tau versus gamma or shear stress versus shear strain relationship is something linear like this. Hence, we will get a single value of this shear modulus from this curve. Whereas, for actual material or most of the material, like for soil, we will get, it will behave like a nonlinear material, where the shear stress versus shear strain of the material will behave nonlinearly like this. And if we want to find out the slope of that curve, that will keep on changing at different point. The initial tangent of that will be considered as maximum shear modulus or G max. If we want to find out shear modulus at any higher shear strain value, then from that point, if we join to the initial point, then the slope of that line will give us the secant shear modulus. And if we draw a tangent at that curvilinear portion of that material behavior, the slope of that line will give us the tangent shear modulus. Now, where these three shear modulus are used for equivalent linear analysis, we use G secant modulus. For linear analysis, of course, we use G max, and for nonlinear analysis, we use the G tan. Then we have seen how we carry out the equivalent linear approach. We generally define the material property in terms of G by G max, non-dimensional parameter in the y axis. So, maximum value of this G by G max ratio will be obviously 1, and as the shear strain increases, which is plotted in the x axis in the log scale, the material degradation will show like this for a soil, and we will say that it is almost close to 1 G by G max value for very low shear strain. That is called the linear range, where G equals to G max for low strain. For that, the low strain range should be within 3 into 10 to the power minus 4%. Now, how to find out this G max value or maximum value of shear modulus? The measurement involves basically the three major methods. One is direct field measurement by using these techniques, or indirect field measurement by using these techniques, or laboratory measurement using these techniques. Also, from the shear wave velocity value, Vs value, we can calculate the value of G max using this relationship, using this density of the material or density of the soil as rho. Now, coming to various relationship of this G value with respect to SPT N value, that is standard penetration test N value, several researchers has obtained correlation between the corrected SPT N value, which is N160, with respect to Gmax. Also in the laboratory, one can find out using resonant column test like this, that what is the value of Gmax at the resonant frequency from this plot of the distortion at different frequency on the resonant column, the torque applied on it. Also from cyclic triaxial test, one can find out the Gmax value. Another way to obtain the Gmax value is from in situ test parameters using various empirical relationships which are available worldwide, like SPT N value, CPT cone penetration value, DMT dilatometer test value, PMT pressure meter test value. So, from each of these tests we can get these empirical relationships for different types of soil as proposed by various researchers worldwide. But we need to remember these relationships are developed for a limited number of data set point and also for a typical soil of that region. So, acceptability of these empirical relationships is always needs to be checked when somebody is trying to do a rigorous analysis for obtaining the Gmax value and further use of that Gmax for dynamic analysis. The variation of this G by Gmax with respect to cyclic shear strain for different values of plasticity index was reported by Vucetich and Dobry in 1991, which shows like this type of variation, and also with respect to the number of cycles, that is, if number of cycle increases, then there will be a change in the Gmax value. Obviously, it is going to decrease, as can be seen from here. The another important parameter, damping behavior, which we have discussed in our previous lecture, like at low strain we will expect low damping ratio, whereas at high strain we will get high damping ratio value. And the variation of damping ratio with respect to cyclic shear strain for a typical soil material will be something like this. This result is also given by Vucetich and Dobry in 1991 for different values of plasticity index for fine grained soils. Now, worldwide there are developments on the SPT N value versus the shear wave velocity relationship, because many a times people cannot obtain the dynamic shear wave velocity at the soil site or field. So, instead of that, people can reasonably use from the static test, which is nothing but static penetration test, SPT N value, the value of Vs, which further can be used to compute the Gmax value and for further dynamic design. So, how it is done? The example we had discussed in our previous lecture for soil of Bangalore region in India, Sitaram et al. In 2006 proposed this empirical relationship Vs in terms of the corrected SPT N160 value, also corrected with respect to clean sand. So, N160 CS, in terms of that, how one can obtain the Vs value in absence of the actual data obtained through field test for the Vs value. Also, for other types of residual soil and silty sand and sand silt, the upper bound and lower bound equations were proposed by these researchers. Another group of researchers, they had proposed for soil of Chennai region in India, Bhuminathan et al. In 2006, for clay soil and for sandy soil, the relationship between Vs and corrected SPT N value. Then the application of research for dynamic soil characterization of Mumbai city, we had started in our previous lecture, and the reference for that I have mentioned that Sumed Y. Maske's PhD thesis, Dr. Sumed Maske, who completed his PhD in 2011 at IIT Bombay under my supervision. So, first we had discussed what are the various hazards for Mumbai city, that is shows the need of doing the study of geotechnical earthquake engineering for Mumbai city. This is the seismic zonation map of India as per IS 1893 part 1 of 2002 version, which places Mumbai city in zone 3, and these are the 7 original islands of Mumbai city, which has been combined together by landfilling etc. over the period of time. And these are various earthquake history in and around Mumbai city, which has been reported in this journal paper by Maske and Chaudhary 2010, Journal of Applied Geophysics, Elsevier. This GIS based map shows the original 7 island of Mumbai and the surrounding marshy land, that is reclaimed land around Mumbai city, which actually formed today's Mumbai city. Some other necessary information to study the Mumbai city area for this seismic hazard analysis. First of all, location of the Mumbai city is in seismic zone 3 as per IS 1893 2002 version part 1. So, earthquake of 6 to 6.5 intensity or magnitude is possible to occur. Past disastrous earthquake occurred in the peninsular India, not exactly in Mumbai, but in peninsular India, and Mumbai is also a part of that. The Mumbai city population is more than 15 million as per the census of 2011. Active fault zone are present close to Mumbai, like Panvel Flexure, Thane Creek and Dharmatar Creek, as mentioned by these researchers. Also, there are various 23 small active faults in and around Mumbai city, as mentioned by Raghukanta Nayangar in 2006. So, with these details, we had completed our previous lecture. So, let us see how to take it forward today in our present lecture. Now, when we want to do any dynamic soil properties study on that for the Mumbai city, first we should know the typical soil property of Mumbai. So, to find out the typical soil property, you can see in this slide that for the entire Mumbai region, various numbers of borehole data has been collected from reliable government and private agencies, so that we get the soil profile of entire Mumbai city in this fashion. And this GIS based map shows the locations of boreholes which are collected all around Mumbai city, which is available in the paper of Maske and Chaudhary 2011 Geotechnical Special Publication of ASCE. This is a typical soil profile for the Mumbai city at various locations like Girgaon, Wadala, Andheri, etc. And this table shows the various stations, borehole stations, various soil types, their depth, SPT N value corrected, originally recorded, corrected, groundwater depth, and various other soil parameters like amount of gravel, sand, silt, clay, liquid limit, plastic limit, specific gravity. So, all these informations were collected from reliable and authentic borehole data from various locations like Tilaknagar, Chembur, Mulund, Wadala, etc. This chart shows the worldwide used correlations available for SPT N value versus the shear wave velocity Vs value. Like for all types of soil, Oba and Torumini in 1970 proposed this equation of Vs versus N. Also, several other researchers, as shown in this table, have mentioned different equations of Vs versus M as reported over here, which are used worldwide extensively, and the details are available in this paper by Maske and Chaudhary 2011 in the journal Natural Hazards, published by Springer. So, in this we should again remember that these empirical relationships were developed based on the soils collected from a particular region, and also it is based on a certain number of data set points. So, application of these equations for any particular region, one has to be very careful whether that type of soil exists at the same area or not, or whether the soil behavior at the location is similar or not. If not, then obviously this relationship should not be used, and a new relationship is required to be developed for that particular area. So, now let us look at here that when we want to develop some particular relationship of that SPT n value versus the shear wave velocity Vs for Mumbai region from the collected borehole data, you can see over here, these are the typical average shear wave velocity values all around Mumbai city at various borehole locations which are digitized in the GIS map. These details are available in this paper. Also, these stations and soil type, depth, SPT n value are shown over here, and this is the equation which has been developed for Mumbai city by Maske for his PhD work under my supervision, and these are the ranges of values of SPT n value and corresponding shear wave velocity value in and around Mumbai at different locations. So, one can easily see it is not in the similar range in all the places. It depends on location to location, it varies from location to location. So, one needs to be very careful when somebody is planning to do any earthquake engineering study or analysis or design at different locations of Mumbai, incorporating these dynamic soil properties. This result shows the correlation between shear wave velocity in the unit meter per second versus SPT n value, and this is uncorrected SPT n value, it may be noted. So, from the present study, this is the observed and proposed equation, that is Vs equals to 72 n to the power 0.4 for entire Mumbai city soil, and field observed or field measured actual shear wave velocity at 3 different locations are obtained at different values of SPT n value, and corresponding Vs values are plotted, which are matching very well with the proposed entire region Mumbai soil. This result shows the correlations between shear wave velocity Vs in meter per second unit versus the clean sand corrected SPT N160 value. So, this is clean sand corrected SPT n value. You can see the equation proposed here is Vs equals to 40 N160 Cs to the power 0.47. So, there is a minor change from the uncorrected SPT n value to the corrected SPT n value. This is observed from the Dr. Maske's PhD thesis as reported over here. And also it was concluded from this study that there is hardly any large variation or significant variation between the use of original raw SPT n value or corrected clean sand SPT n value, also by previous other researchers. Why? Because there are several uncertainties involved in the SPT n value corrections also. So, instead of adding up the uncertainties, it is also suggested that for basic study or first step of study or design, it is better to use the basic equation of Vs equals to 72 n to the power 0.4 for the Mumbai city soil from the uncorrected SPT n value, where it will give reasonably correct result for the shear wave velocity, as it is also verified and authenticated from the field measurements as shown in this slide. Now, coming to this comparison of various Indian soils, what are the different correlationships available between shear wave velocity Vs and uncorrected SPT n value, as reported by 4 researchers group for 4 different city, as on today it is available like this, that is shear wave velocity Vs in meter per second unit in the y axis, and in x axis it is SPT n value uncorrected. This line, the top one, shows the results for Delhi city, which is given by Hanumant Rao and Ramana 2008, that is the researchers from IIT Delhi. They have developed this equation Vs equals to 82.6 n to the power 0.43 for Delhi city. This is the equation proposed to be used, whereas Anbazagan and Sitaram in 2010, this lowermost line with the circles symbol, they proposed for the Bangalore city Vs equals to 80 to the n to the power 0.33 as the proposed equation for the soil of Bangalore city. Maheshwari et al. In 2010, as shown by these dark triangles, which is for Chennai city, Vs equals to 95.64 n to the power 0.301 is the proposed equation for soils of Chennai city. And for Mumbai city, the present study shows the results, which is star marked over here, this one, Vs equals to 72 n to the power 0.4 is the proposed correlation for Mumbai city soil, that is from SPT n value how to calculate the shear wave velocity. So, it can be seen that for these 4 major cities in India like Delhi city, Bangalore city, Chennai city and Mumbai city, these are the corresponding proposed correlations between SPT n value and the shear wave velocity Vs value, which will help finally to compute the maximum shear modulus Gmax value from this Vs value for that particular region of soil, and that will be finally used for the seismic design of any structures in that locality. In the similar fashion, it is today's necessity that for most of the seismically active region or important locations where major construction is required or proposed, there to carry out the seismic design or earthquake resistant design, it is necessary to find out this kind of relationship of Vs versus SPTN, because at many places we will not be able to carry out the shear wave velocity test at field due to several reasons. One of that, as I have mentioned in previous lecture, because of presence of several obstruction. If obstruction is present, many a times SASW, MASW results will give us the wrong result, because it is not giving the result of that Vs value of that particular soil, but it is giving a result of shear wave velocity passing through composite material, that is whatever structure or hidden objects are present in the soil, that material including the soil, that does not capture the exact value of the stiffness or shear wave velocity etc. of that particular soil. So, that is the reason why it is also proposed worldwide, and also in India it is today's need to find out this kind of Vs versus N relationship for most of the important cities and locations and the seismically active regions. This GIS based map shows the thematic map of average soil shear wave velocity more than 100 meter per second for the Mumbai city. You can see over here all these red color patches are nothing but those region where shear wave velocity, average shear wave velocity to a particular depth is greater than 100 meter per second. So, one can say these are relatively stiffer soil compared to other regions. So, Maske and Chaudhary 2011, this natural hazards journal paper in Springer is available with all these details. This GIS map shows the geospatial contour map of average soil shear wave velocity Vs with interval of 50 meter per second for typical soil of Mumbai city. So, with 50 meter interval, 50 meter per second interval, the shear wave velocity values are plotted and shown over here like 140, 190, 290 etc. 240 are shown over here, which is useful. Why? Because if somebody is planning to do any construction at any region, say at Malad region, then they know at this location typically, remember this is the typical representation, it may vary within that location also, but typically the range of shear wave velocity will be within this value whatever is mapped over here. So, these details are very much useful for practicing engineers and design engineers to further carry out the design, earthquake resistant design or earthquake related design at that site. This GIS based map shows the value of maximum shear modulus Gmax value where it is more than 20 MPa for Mumbai city. How it is obtained? From the values of Vs, it can be easily computed the Gmax value knowing the density of the soil. So, through that the Gmax of more than 20 MPa, those locations are marked over here. That means, these are relatively stiffer soil zone. Now, this table shows the classification of the soil site into 5 different categories like soil class A, B, C, D, E, with their description as hard rock, rock, very dense soil and soft rock, stiff soil and soft soil, based on the dynamic property of the soil, which is expressed in terms of average shear wave velocity Vs 30. What is 30? 30 indicates the average shear wave velocity up to a 30 meter depth from the ground surface. So, that is why this number 30 came here. So, Vs 30 of the soil in the unit meter per second, that value is used to classify the soil into different classes. This soil site classification is based on as per NIHARP standard of 2000, which is nothing but Codal guideline or provision as mentioned in USA and practiced worldwide. So, for soft soil, Vs 30 value will be less than equals to 180 meter per second. For stiff soil, it is between 180 to 360 meter per second. For very dense soil, it is between 360 to 760 meter per second, and so on. So, Mumbai soil, what study has been carried out Dr. Maske for his PhD thesis at IIT Bombay, it has been observed that most of the soil of Mumbai region comes under soil class D or E, that means stiff soil and soft soil, because their Vs 30 value found out to be within this range of between 100 to 360 meter per second, as mentioned over here. Now, coming to the another important topic, subtopic, that is soil liquefaction. First, I will mention that for the detailed basic understanding of soil liquefaction, one should refer and listen to my another video course, that is on soil dynamics, which is developed for this NPTEL course once again. And for that soil dynamics video course, module number 4 also discusses about this soil liquefaction. What is soil liquefaction? As mentioned in this book by Kramer in 1996, it is nothing but the transformation from a solid state to a liquefied state as a consequence of increased pore pressure and reduced effective stress for soil. And as mentioned by Osinov in 2003, if the shear resistance of the soil becomes less than the static driving shear stress, the soil can undergo large deformations and is said to liquefy. So, in the state of soil liquefaction can occur due to several dynamic loads, but earthquake is of course one of the reason. So, due to earthquake also soil liquefaction can occur. Now, soil liquefaction due to earthquake, modern liquefaction engineering developed after Niigata 1964 earthquake and Great Alaskan earthquake of 1964. After that, the research etc. extensively started in this area of soil liquefaction. So, key elements of soil liquefaction as proposed by Seed et al. In 2003 are mentioned over here, and we should always remember that every new earthquake, whenever another earthquake comes, it creates a new research area, because we get lots of more data, lots of more understanding about how the soil behaved during and after the earthquake. So, all those information, whether it got liquefied, if it has been liquefied, what type of soil was there, if it has not liquefied during a magnitude of earthquake, why it has not liquefied, what are the characteristics of the soil, and then try to correlate between various physical and engineering soil parameters with respect to the liquefaction estimation and so on. So, this assessment of likelihood of triggering or initiation of soil liquefaction needs to be carried out. Then assessment of post liquefaction strength and overall post liquefaction needs to be studied, because after the liquefaction how much strength of the soil is remaining, whether it can be further used for construction of structure or not. These are important to know. Assessment of expected liquefaction induced deformations and displacements, assessment of consequences of these deformations and displacement, then finally, the implementation and evaluation of engineered mitigation if necessary at that site. Now, susceptibility of the soil to earthquake induced liquefaction, these are the parameters which influences, like of course, earthquake intensity and duration, what type of soil is present there, then soil relative density, particle size distribution of the soil, presence or absence of the plastic fines, groundwater table location, that is amount of degrees of saturation, hydraulic conductivity or permeability of the soil, placement conditions or depositional environment of the soil, aging and cementation of the soil structure, overburden pressure, and finally, the historical liquefaction. So, all these factors which influences the earthquake induced soil liquefaction. Now, liquefaction susceptibility criteria, there are several methods as can be seen over here. For fine grained soils, there are various methods to obtain the liquefaction susceptibility criteria, both for fine grained as well as coarse grained soil. Chinese criteria and modified Chinese criteria, Andrews and Martin criteria of 2000, Ude et al. 2001 criteria, Seed et al. 2003 criteria, Bray et al. 2004 criteria, Bray and Sanshio 2006 criteria, Boulanger and Idris 2006 criteria, and various other studies. So, among these, the most important or maximum widely used one is this one. This is by Ude et al. 2001. This is maximum used worldwide for the liquefaction susceptibility estimation. Coming to Chinese criteria and modified Chinese criteria, Chinese criteria was developed by Wang in 1979 based on the study on Heichen and Sangchen in 1975 and 1976. The criteria says that the percent finer than 0.005 mm should be less than 15%, liquid limit should be less than equals to 35%, and water content should be greater than 0.9 times of liquid limit for that fine grained soil. This criteria is basically for fine grained soil. So, this is the typical plasticity chart, as we know, liquid limit versus water content. This is the A line equation. So, modified Chinese criteria says that the fine soils that the plot above this one, the A line shows in the figure, are considered to be susceptible to liquefaction if these three conditions, that is percent of clay present in the soil is less than 15%, liquid limit is less than equals to 35%, and in situ water content is greater than or equals to 0.9 times liquid limit. Then the Ude et al. 2001 criteria is a combination of several other researchers' findings, and this is a kind of report or methodology proposed which is accepted worldwide so far. So, Seed et al. In 1985 developed the ratio of the CRR versus CSR curve for granular soil. CRR is cyclic resistance ratio and CSR is cyclic stress ratio. The details about these things I have already discussed in my another video course for NPTEL, that is on soil dynamics. So, I request all the viewers of this course also to go through my another video course on soil dynamics, module number 4 of that course. So, we can get all these basic details, I am not covering it here. So, it has been proposed how to estimate this cyclic resistance ratio or CRR from corrected blow count SPT N160. So, these are all the collected historical data points of earthquake from actual field test results, that where the soil got liquefied and where it did not liquefy. That shows the three curves, like percent fines less than equals to 5%, another is between 5 to 15%, this range between 15 to 35% and more than 35%. So, like that, this percent fine, if it is less than equals to 5%, then it is called SPT clean sand based curve. and clean sand correction also required to be computed to estimate the CRR value from this curve. And Seed et al. In 2003, they proposed, these are the recommendations for fine grained soil, that is plasticity index versus water content or liquid limit, water content to liquid limit ratio in the x axis. They have divided into different 3 zones, that is susceptible to liquefaction, moderately susceptible and non susceptible. So, accordingly, if somebody wants to put their soil in this region and try to find out whether it is coming in susceptible range or non susceptible range, this recommendation may be used. Further, Bray et al. In 2004, they proposed another methodology using the similar concept of plasticity index versus water content to liquid limit ratio like this, and mentioned that liquid limit is not considered, as the authors observed that a number of specimens with liquid limit greater than 35% were found to be moderately susceptible to liquefaction. Another set of researchers like Bray and Sanchio in 2006, they proposed a criteria based on 10 numbers of cyclic simple shear test performed for the same soil specimen, in addition to the test carried out as we have explained in the previous slide just now. Some observations of Chichi earthquake of 1999 as reported by Chu et al. In 2004 are also incorporated in that, and in the same pattern of plasticity index versus the water content to liquid limit ratio have been zonified into 3 zones. One is susceptible to liquefaction, another further testing is needed, and another is not susceptible to liquefaction zone. Another criteria is mentioned by Boulanger and Idris in 2006, where CRR of clay like material and CRR of sand like material has been considered as 2 boundaries with respect to the x axis plot of plasticity index Pi. So, for different values of plasticity index, the typical range from transition of sand like to clay like soil behavior is mentioned by these researchers, which is showing the exhibit of cyclic liquefaction. So, fine grained soils having plasticity index less than 3 are named as sand like, and they can exhibit the cyclic liquefaction type response. Whereas, for fine grained soils with plasticity index greater than 7 are named as clay like material, where they are expected to exhibit cyclic mobility type response. So, in one case it is cyclic liquefaction and another case it is cyclic mobility, depending on whether it is sand like behavior or clay like behavior. And in between range, that is when plasticity index is between 3 to 7, a transition between this sand like to clay like behavior is proposed to occur, and this figure provides a schematic illustration how this transition from sand like to clay like behavior is occurring. So, this criteria in the CRR versus plasticity index domain without a scale, and distinction of sand like and clay like fine grained soil is based on solely on the plasticity index on the specimen, and RU value, that is pore pressure ratio, as it is mentioned over here, excess pore pressure ratio for sand like soils. Initial liquefaction is achieved when excess pore pressure ratio RU becomes equals to 1. So, if it is less than 1, then it is not liquefying. Whereas, for clay like soil, it undergoes cyclic mobility when this RU value exceeds 0.8. So, for sand like material, it has to be equals to 1, so that one can say liquefaction is going to occur. For clay like material, it should be more than equals to 0.8, then one can say it is going through the cyclic mobility. So, this RU based liquefaction susceptibility definition, it requires the determination of CSR levels and the duration of the excitation. So, these things are the topic of research even on today in this year 2013. Still further researchers are carrying out their various research from the collected field test data of liquefied zone, non-liquefied zone, transition zone, etc., and also doing the laboratory test and combining this data set of results, as many data set are possible. So, that this interpretation of results and then further proposing some new criteria will be valid and can be used by various researchers. Now, coming to the seismic liquefaction hazard map of Mumbai city using this GIS and GPS. The details of this work can be obtained in this journal paper by Maske and Chaudhary 2010 in Journal of Applied Geophysics, Elsevier publication, volume 70, number 3, page number 2162 225. The evaluation of soil liquefaction, like how it was carried out from the entire set of borehole data collected for the entire Mumbai region, as the dynamic soil properties, the VS value has been estimated and reported just few slides back, as we have discussed here. Then for each borehole locations, the soil liquefaction susceptibility is estimated using the simplified procedure for evaluation of liquefaction potential. The simplified procedure was basically proposed by Seed and Idris in 1971. Further, it was modified by Ude and Idris in 1997, and the final one is Ude et al. 2001, which is widely used worldwide, as I have mentioned. So, discussion about this simplified procedure to evaluate the liquefaction potential is available in my another video course of NPTEL, which is on soil dynamics. Module 4 of that discuss about the simplified procedure for liquefaction estimation. So, these are the stepwise procedure. In step 1, the surface data used to access liquefaction should include location of groundwater table, SPTN value, shear wave velocity value, unit weight of soil, fines content of the soil, moisture content. In the step 2, evaluate the total vertical stress and effective vertical stress, that is sigma V and sigma V dash for all potentially liquefiable layer within the deposit, and then one need to calculate the cyclic stress ratio or CSR as induced by the design earthquake. So, for a particular region, we all know what is design basis earthquake as per the codal provisions or the zonation map or the seismic microzonation point of view. One can find out what is the value of this Amax for a region. That Amax value can be used. This G is acceleration due to gravity. So, this is just a number. RD is nothing but stress reduction factor due to flexibility of the soil, and the sigma V is total vertical stress and sigma V dash is effective vertical stress. So, with that a non-dimensional parameter CSR cyclic stress ratio can be obtained, which is proposed by Seed and Idris in 1971. Now, how to select this stress reduction coefficient RD? There are various researchers who had proposed different ranges or values or equations for RD. We can see over here, as we go deeper and deeper inside the ground from the ground surface. So, from this ground surface where the depth is 0, if we go deeper below the ground, as the depth increases in meter unit, it is shown over here, the RD value reduces also from 1 to this one. So, 1 means there is no correction or stress reduction coefficient in this equation is not required. 1 means that is at ground surface, but as we go deeper, because of flexibility of the soil, this stress reduction coefficient needs to be incorporated. One can see Idris in 1999 proposed this line to calculate the value of RD for a certain value of MS, which is certain value of Vs, shear wave velocity 120 meter per second, magnitude of moment magnitude of earthquake is about 6.5, PGA value of 0.2 G. For that, this is the line, whereas Kishida et al. 2009, Kishida et al. 2009 mentioned this line to be used, whereas Setin et al. 2004 mentioned this value to be used. Whereas, for another range of same soil, that is Vs value 120 meter per second, but under higher magnitude of earthquake, when higher magnitude of earthquake MW of 7.5 is coming at that location, these are the values of RD as proposed by different researchers. It is adapted from the research paper of Idris and Boulanger of 2010. One can easily see that there is a wide variation in the value of this R d, which can influence this calculated value of the CSR. So, it is a question which is the correct value to calculate this R d. So, in absence of the correct value, one can easily use the method proposed by Yu et al. 2001 to calculate the reasonable range or value of R d. Then cyclic resistance ratio, another parameter CRR, at the reference magnitude of 7.5 can be calculated using SPT data of N160 using this expression, which is known as Blake's equation as proposed by Blake, which is available in the paper of Yu and Idris 1997 and also Yu et al. 2001. These are the x is in this equation, x is nothing but N160 corrected SPT n value, and various coefficients a, b, c, d, e, f, g, h all are mentioned over here. And factor of safety against liquefaction is computed using this expression. Factor of safety against liquefaction is nothing but CRR 7.5, 7.5 is nothing but at the moment magnitude of 7.5. If the earthquake of that zone for which the design is considered is different than 7.5, then corrections due to the magnitude correction needs to be carried out. So, CRR by CSR will give the factor of safety with respect to liquefaction. Using this concept, this paper of Musk and Chaudhary in Journal of Applied Geophysics Elsevier classified the three ranges of factor of safety with respect to liquefaction, their value, to identify or remark their soil as critically liquefiable, moderately liquefiable and non-liquefiable soil. What is critically liquefiable? When factor of safety less than 1. When factor of safety is between 1 to 1.3, it is mentioned as moderately liquefiable soil, and when factor of safety is greater than 1.3, it is considered as non-liquefiable soil. So, using these ranges of factor of safety for entire Mumbai city in this paper, the calculations for factor of safety against liquefaction with respect to depth and with respect to all boreholes were carried out. Finally, this is the GIS based map for entire Mumbai, which shows the critically liquefiable area. Critically liquefiable means in these locations, in these patches as shown by this color, that shows a critically liquefiable area in Mumbai at a moment magnitude of 6. So, that means if a moment magnitude of 6 earthquake comes in Mumbai, these are the region where soil is going to liquefy as the present scenario is concerned. Critically liquefiable means factor of safety with respect to liquefaction will be less than 1. This is another liquefaction hazard map for Mumbai city, which shows for moment magnitude of 7.5 if it comes in Mumbai, these are the region where it is going to critically liquefy, and one can easily see these are nothing but the areas where it is the reclaimed land. So, that is why it is another kind of validation that as we know the reclaimed land or filled up land are more prone or susceptible for liquefaction during an earthquake, which is also got validated from the property and from this liquefaction hazard map. So, how people can use this hazard map for further design? So, if somebody is planning to construct any big high rise building in these locations, which is quite possible in Mumbai city, extra design care and design measure needs to be taken for the foundation design and other design. Like if somebody is constructing a pile foundation in these locations, then pile foundations need to be designed with respect to the liquefiable zone, which I am going to discuss in subsequent lecture modules in this course. This table shows the various values of factor of safety against liquefaction for entire Mumbai city as obtained in this journal paper by Musk and Chaudhary 2010 in Journal of Applied Geophysics in Elsevier publication. One can see these are the different site address like Andheri, Bhandup, Borivali, Bandra, Malad, Dahisar, etc. So, factor of safety against liquefaction for different moment magnitude are mentioned over here, like moment magnitude of 5, 5.5, 6, 6.5, 7, 7.5, all values are given over here. One can see the non-bold values are perfectly fine. That means, if in Mumbai magnitude of 5, 5.5 earthquake comes, there is absolutely no problem in terms of liquefaction is concerned in these mentioned 10 locations, in these 10 sites. But if magnitude of 6, 6.5 or more than that comes, the soil tends to start liquefying at certain locations, like one can see at Bhandup West, if a magnitude of earthquake magnitude 7.5 comes, the soil is going to critically liquefy, that is, it is going to fully liquefy. That means, the factor of safety less than 1, even at magnitude 7 also. Similarly, for other locations also, the values are given over here, which is very much useful for any designers to utilize this concept to further take protection and necessary design steps and methodology and construction steps for earthquake resistant design in and around Mumbai city using this data. So, in concluding remarks, we can say that typical shear wave velocity what we have obtained for the soil in Mumbai region between 3 meter to 10 meter range varies typically between 140 to 350 meter per second, and typical areas like Kandivali, Borivali, Goregaon, Malad of Mumbai city can be prone to critically liquefiable condition when an earthquake magnitude of 7.5 hits in and around Mumbai. The soil amplification factor for Mumbai, which has been obtained earlier, it can range between 2.5 to 3.5 if a similar type of Bhuj earthquake motion of 2001 hits Mumbai city. And from this known knowledge of geotechnical earthquake engineering, one can further take precautionary measure to find out what are the significant effect of depth of this liquefying layer, which needs to be considered for design of pile foundation and any other type of foundation, even for shallow foundation also, which are necessary to incorporate in the design. So, with this we have come to the end of present module, module number 6. We will continue further in our next lecture.